Hi, welcome to part 9 of the video series about work and energy. We worked through some examples involving the conservation of mechanical energy in the previous video. In this video, we will define the work-energy theorem. Consider an object with mass m and initial velocity of vi. Under the influence of a net force, it moves to the right and eventually reaches the final velocity of vf. We must determine the net work done on this object. The problem is that no information has been given regarding the magnitude of the net force and displacement. In the steps that follow, we will use maths to figure out how to calculate the net work done on this object. We will get a single equation at the end that we may utilize for all further calculations. You are free to skip the maths part and move right on to the work-energy theorem, as this is the main equation we will need for our exams. We can do so by clicking on the timestamps in the description of the video. Let's start with writing down the formula of the work done by the net force. Net work is equal to the product of the net force, displacement of the object, and the cosine of the angle between these two. Neither net force nor displacement are given in the diagram above. Let's try to see if we can somehow determine them. As we know from the second law of motion, the net force is equal to mass of the object multiplied by its acceleration. Then we need to recall one of the equations of motion from grade 10. Square of the final velocity of the object is equal to the sum of the square of initial velocity and 2 times displacement of the object times its acceleration. After some altering with the formula, we can identify the displacement as v final square minus v initial square over 2 times acceleration. Finally, in the case above, the angle between the displacement and the net force is equal to 0. Consequently, cosine of 0 equals 1. With these expressions, we can now replace net force and displacement in the formula for work. Instead of net force, we write mass times acceleration and displacement as v final square minus v initial square over 2 times acceleration. We can omit cosine theta as its value is equal to 1. The equation can then be simplified because accelerations will cancel each other. As a result, net work is equal to mass times difference of squares of final and initial velocities over 2. After some refactoring, the equation can be expressed as 1 over 2 times the mass times square of the final velocity minus 1 over 2 times the mass times square of the initial velocity. Using the formula 1 over 2 times mass times square of velocity, we can calculate an object's kinetic energy, as we learned in earlier lessons. In other words, the net work is equal to the difference between the final and initial kinetic energies. Based on this final expression, we can define the work-energy theorem. The net or total work done on an object is equal to the change in the object's kinetic energy. Change in physics is denoted as delta. Thus, the net work done on an object is equal to delta of kinetic energy. In this video, we learned about the work-energy theorem. In the next one, we are going to see it in action while solving some examples. Thanks for watching. Don't forget to subscribe and turn on notifications in order to be updated about the new videos.